Have you ever wondered why commercial airplanes don't provide parachutes for each passenger in case of an emergency? And so they could use them to jump out of the plane and save themselves? Well, that's a very good question, and it really could save hundreds of lives. Just like the ejection seats in military jets have been doing since they were first used in 1942, saving the lives of hundreds of pilots from fatal accidents. If you're considering adding these seats to commercial airplanes, it's best to drop that idea. Besides being robust, the whole ejection process is quite violent, often resulting in bone fractures and spinal injuries. And the pilot experiences 14 to 16 Gs in some cases. In addition, after activating the ejection mechanism, a command is also sent for the pins holding the canopy to be blown off. Removing the canopy lets the pilot pass through, which can't be done in a commercial airplane because that would require making several holes in the fuselage roof. And it's in the ceiling that several pressurization tubes, electrical cables, and various systems run. The overhead bins are also in the ceiling. But then, why not distribute individual parachutes in case of an emergency? Well, first we have to define the types of parachutes, and there are basically two types: the round parachute, the rectangular parachute. The round one is used in the military world for dropping troops and cargo, and this parachute is not maneuverable. Whoever is using it just falls slowly toward the ground with no maneuverability at all. The rectangular one is maneuverable. It's the main parachute used in skydiving. Whoever is using it can maneuver and choose the place they want to land with good precision. The rectangular one isn't usable for emergencies on an airplane. It requires quite extensive training before use. In other words, an ordinary passenger who has no experience with it wouldn't be able to use it. So only the round one remains, which isn't maneuverable and just falls slowly anywhere. That one can be used. And here come the problems. The first relates to the airplane's evacuation time. Taking into consideration that on average an airplane carries between 150 and 200 passengers, and assuming a jump interval of 5 seconds, that is, one passenger jumps and after 5 seconds the next one, it would take 12 minutes to evacuate an airplane with 150 passengers, and 16 minutes to evacuate an airplane with 200 passengers. And that's such a long time that the plane could already be on the ground before even half of the people managed to escape from it. Another issue is maintaining airplane stability during evacuation. The airplane needs to be stable. When it comes to mass evacuation, one of the problems that can lead to this scenario is serious failures in the airplane itself, such as loss of a wing, total loss of control, or a rupture in the fuselage. In other words, serious or structural failures. Because if all the engines of the plane stop working, it doesn't mean an imminent accident. Because a plane can still glide for hundreds of kilometers even without its engines. In a structural failure like losing a wing, the plane would be totally uncontrollable, spinning or in a dive, which makes evacuation impossible. But even if the plane is perfectly stable, not all doors can be used for the jump. It's important to remember that during cruise flight, planes fly at typical speeds of 780 to 900 kilometers per hour. In other words, jumping from the front doors, the person is thrown backward and runs a serious risk of being immediately sucked into the engines. But even if the engines are off, the person can still hit their head or even their body against the wings and the engines. Emergency doors or emergency windows over the wings also wouldn't be a good option. That's because on some planes these doors are quite narrow. This would increase evacuation time per person, as would the presence of the wing itself. So only the rear doors of the plane remain. And since there are only a few of them, ranging from 2 to 4 doors depending on the plane, evacuating 200 people through just 2 doors would take a long time. And there's an important detail I haven't mentioned yet. It's impossible to open any door of an airplane while in flight. Yes, it's impossible to open any door or emergency exit of an airplane while it's in flight because of the pressurization. As the plane climbs higher and higher, the outside air becomes thinner. In other words, there's less oxygen. And so people can breathe. The plane is constantly pressurizing the cabin with air taken from inside the engines. This air, which is taken from the engines and constantly pumped into the cabin, creates pressure. And it's exactly this pressure that prevents any door from being opened. It's like opening a pressure cooker lid with pressure still inside. And the airplane doors are already designed to close from the inside out, constantly keeping the door pressed against the frame, precisely so it doesn't burst open with all the pressure inside the cabin. So the internal pressurization is constantly pushing all the doors against the frame, exactly like in a pressure cooker, making it impossible to open them. To give you an idea, the force that pressurization exerts on a door can reach 8 pounds per square inch in airplanes like the Boeing 777. Just think about that. There's a force of 8 pounds for every square inch of the door's area. And the only way to open an airplane door in flight is by completely depressurizing the passenger cabin. And if that's done, the passengers need to be wearing an oxygen mask. Now, imagine how long it would take after an emergency happens for the plane to be depressurized, for 200 passengers to put on their oxygen masks, which would have to be portable, put on their parachutes, get a quick briefing on how to use them, and then jump out of the plane. Think how long that would take. It's important to remember that opening an airplane door at 700 or 900 kilometers per hour carries a serious risk. In fact, it's almost certain that doing so would completely break apart the plane because of the tremendous wind force, which is even stronger than a Category 5 hurricane. But even putting all that aside, there are still several other problems. The other problem is the outside temperature. The outside temperature at the high altitudes where airplanes fly, typically at 30,000 feet or 9 kilometers high, ranges from minus 30 degrees Celsius to minus 60 degrees Celsius depending on the region. Imagine during an emergency on top of the general panic, the door is opened and a gust of air at minus 50 degrees Celsius comes in. Besides that, for parachutes to work during the fall, the person using it needs to open it manually. And if the person faints during the fall for some reason, the parachute must have an automatic deployment system, which makes the parachute much more expensive. And parachutes only work well from certain altitudes. At high altitudes, they don't work very well due to the thin air. And to make things even worse, there's the fear of parachuting. A lot of people would be afraid to parachute. Many people would have to be pushed to jump. A lot of people would panic. They would faint. They would become hysterical. And there are elderly people on board a plane. There are children. There are babies on board. So it would be complete chaos and a terrible situation. And even after parachuting, that doesn't exactly mean you've survived a possible plane crash. It's important to remember that planes cross deserts, remote areas, and oceans. Some people on board, for example, can't swim. There's a chance they could land safely in the open sea but end up drowning. And even with life jackets, it could take a rescue team several days or even weeks to locate the area where people landed in the middle of the ocean and rescue them. Also, because of the time between jumps, everyone would land in different places, which makes the rescue and survival time even more complicated. It's also important to remember that a large part of air accidents don't happen during cruising flight, but rather during landings and takeoffs. And trying to evacuate 150 or 200 people shortly after takeoff, or even near landing, would be impossible. There wouldn't be enough time, and some parachutes wouldn't open fast enough to prevent fatal falls at low altitude. And I left out an important fact, which is the weight of the parachute. An emergency parachute weighs about 10 kilos, and if the plane can carry 200 passengers, that's 2 tons of extra weight added to the plane. And to carry this extra weight, the plane needs to burn more fuel, and consequently the flight becomes more expensive. If the flight costs more, the ticket price also increases. In other words, introducing parachutes on board airplanes is a good solution, but it comes with dozens of other problems. most of which are practically impossible to solve. It involves serious risks, drastic solutions, high costs, and has several points of failure. Even if there are parachutes on board, even if the doors can be opened, still, many people might not be able to jump and save themselves simply because they're afraid of parachuting. And even if these people can be convinced to jump or even pushed, this whole process further increases the jump time per person, which decreases the chances of everyone escaping the plane in time. There's still the risk of jumping and landing in freezing waters or a remote area. Isn't there a way to survive a plane crash? Well, there is, and it's already implemented in airplanes, especially in the latest generation planes. It's about the airplane's design robustness. The latest generation airplanes like the Boeing 737 MAX, the Boeing 777, the 777X, the 787, the Airbus A350, and the A380 are extremely robust and safe airplanes, both from the point of view of all the electronic control and mechanical systems, as well as from the point of view of the airplane's own structure. The chances of an airplane like this completely losing control in flight, losing all its engines, losing a wing, or even crashing are very slim. Why not put parachutes on the airplane itself like Cirrus does instead of on passengers to simplify things? Well, first of all, the Cirrus is a small aircraft and it's lightweight. Those are favorable conditions for implementing a parachute. Now imagine putting a parachute on a Boeing 777, which weighs about 260 tons with passengers and cargo on board. Imagine how big that parachute would have to be. Or even on a Boeing 747-8, which weighs about 400 tons and carries 410 passengers. It's been calculated that a parachute for this large aircraft would need as much fabric as 1.5 soccer fields. Imagine the weight of that parachute with all the systems needed for its deployment and proper functioning. Besides that, if the emergency happens shortly after takeoff or close to landing, there wouldn't be enough time for a parachute of that size to open in time. Also, the plane equipped with such a parachute would still descend at a considerable vertical speed even with the parachute. Taking as an example the capsules that carry astronauts, during splashdown, that is the impact with the sea, the seats already have a cushioning system to prevent the astronauts' spines from being fractured, and they are already in a more reclined position to better withstand this impact. And these capsules already land at typical speeds of 25 km/h with the parachute open. Now, imagine the falling speed of a plane like a Boeing 747. It would be enough to break several spines, even with the parachute open. In short, the idea of putting parachutes on commercial passenger planes is extremely complex. It comes with hundreds of problems, many variables, and important points of failure. There are a lot of things that can fail, go wrong, or not happen in time. It involves high risks from the system itself, human skill, among other things. It's probably for all these reasons that we still don't have individual parachutes inside airplanes, let alone external parachutes for the airplane itself. The best way to survive a possible plane crash is for such an accident not to happen at all. And that is achieved by building better and safer airplanes. Airplanes that are more robust and avoid catastrophic failure.